Let's start it. Today's topic is cloning. The cloning of an object means that creating an exact replica of an object. When we clone an object, it means that the new instance of the object is created. When we say that the new instance of the current object is created, means that the state of the new cloned object is same as the state of the current object. So what is the meaning of a state? The state of an object is comprised of all the instance variable contained in the object. Means that suppose there is an object, there is a class called a student, and it contains instance variable name, age, and roll number. And those name, age, and roll numbers are like name is an Amit, roll number is a 20, and age is was 20. Now, when I say that the S1 is an object which contain all these three variables, means the state of an object is the value at the particular moment of a time of the instance variable of an object. Now, when we clone an object, the state of a current object is same as the state of the cloned object, right? And there is no operator in Java which can create an exact replica of the object. Now, we can also do this with the help of assignment operator, but which is not possible. Like, let's take an example why it is not possible with the help of assignment operator of an existing, if you use an assignment operator with the existing object. This is one object S1 of a student class, and we assume that this S1 contains three instance variable like name, age, and roll number. And these three instance variable of an object S1 contains some value. Let's take an example. So this is the state of an object S1. Now, if we try to create a clone with the help of assignment operator, like this way of creating a exact replica of an object, what happens when we do this? With this line of statement, when S1 is created, what happens? The object memory location will be created for an object S1, and all the instance variable will get the value. Okay. Now, when we create a new object S2, it will also get a new memory location S2, and with some values of name and roll number. And then when use the assignment operator to create the exact replica, what happens? Now with this line, S2 will be point to S1, and this object will become an unreachable. Now, this is not exactly the cloning, it is an alias reference variable for an object. Means that with the same object, now we have a two handler S1 and S2. So this is not the right and appropriate way of creating a clone. That is why Java introduced the concept of cloning. Now, the cloning is of two different types. First is a shallow cloning, another is a deep cloning. We will discuss in a moment. Now, before that, what are the criteria to clone an object? There are three criteria. The first is we have a clone method. The first is to use a clone method, which is available in the object class. The object class belongs to the java.lang package, which we have discussed in the earlier lecture. Now, whenever we want to clone an object s1, we can use s1.clone. With the help of this method, a new object or a cloned object will be created with the exact state of the s1. So now we can get an s2 cloned object which is having the same state as of the s1. Okay, we will see in a moment in an example. This clone method is sufficient, most of the time is sufficient for cloning an object, but in some cases we need to override it. When we need to override, we will see when we will do the example. The second is a clonable interface. Now, second is a clonable interface. Clonable interface, what is an interface? Interface, you can assume that it is similar to kind of a class, but we cannot instantiate an interface. An interface itself is a different topic. We will be learning in some other lecture. Now, for the timing, you can understand interface as a class where we cannot instantiate an interface. Now, this clonable interface is an empty interface which we call tag or marker interface in Java. We have few marker and tag interface in Java, and this is very important. This tag interface means the interface which are empty. Normally we say that normally empty interface which do not contain anything are called a tag or marker interfaces. Now you can think if the interface is not having any methods, any variables, then what is the use of that one? You can assume that interface, clonable interface, should look like this, which is an empty interface with the keyword called interface, obviously public return type. So just when you see the Java API, you will see that clonable interface, which is also available in the lang package, java.lang package, and this is an empty interface. If the interface is empty, then what is the use of the interfaces? So that is why these interfaces are called tag interface or a marker interface, which is just a tag or a marker to indicate the JVM that the objects can be cloned. Okay, but clonable interface we will implement just like a class extends, the interface implements. Now, suppose you want to clone an object of a student class, then you need to implement the clonable interface by the student class. In simple terms, student is a class, s1 is an object, we need to clone s1 and make it to the x2. Then we need to implement class student implements clonable, which will be a marker to the JVM that this student class can be called for a cloning. So this is a marker interface, and other interface we have a serializable. Okay, so then we can discuss when we will do the interfaces in detail. Okay, third point in the strategy of cloning is a clone not support exception. Means that whenever an object is not implementing the clonable interface and try to create a clone, then the clone not support exception must be thrown. It means that we need to catch this exception and we need to implement the clonable interface. You can visualize in this sense that a student class is trying to clone an object but is not implementing the clonable interface, then it can throw a clone not support exception. So we need to catch this exception once we clone the object. Okay, when we clone an object S1 to S2, the effect on the S1 there is no effect on the object S1. The object S1 will remain as it is, and the S2 will be the new cloned object, and then you can play with the S2 object without reflecting any changes on the S1. So let's take an example how we can clone the object. So there are two kind of cloning. One is a shallow cloning, another is a deep cloning. So we will discuss with an example to understand the cloning concept. Okay, now we have a one class called test, which is having two variables, a instance variable A and B having the value 10 and 20, and now we want to create a clone of the one of the object of the test class. So let's create an object first. This is a main class, which is just like a client class from where we can run the public static void main method. Now test O1 is equal to new test. We assume that with this line creates an object of the test, and we assume that while creating an object we are able to get the values 10 and 20 in AB either with the help of a constructor or the default initialization. Okay, so we are not getting into the constructor detail. Now this object O1 is containing two variables, instance variable A and B having the value 10 and 20. Now if we want to create a clone of this object, first we need to use these criteria. First one is a clone method. Okay, we will call a clone method. Second is a clonable interface. That means we need to implement the clonable interface. It means that we need to implement, because we need an object of test O1, then we need to implement the clonable interface. Now it is something like extending, but here interfaces are implemented. You have a class, one class, and you want to use in another class an instant hierarchy. You extend. The last time we did, we inherit with the help of extends keyword. Similarly, interfaces are implemented. Okay, interface is a separate topic. You will understand how the interface works in that lecture. Now test implements clonable. That means it is a marker. This is a marker interface. It will tell the JVM that the test objects can be cloned. Okay, the second point we need to call the clone method. Now third is clone not support exception. Whenever we call a clone method, we need to put in a try catch blocks. Okay, either in a try catch blocks or throw a exception in the method. Now clone not support exception is a checked exception. That means it will give a compile time error if you not use the try catch block. So I am putting this in a try catch block. O1 dot clone, and I hope you remember in the last lecture the return type of the clone method is an object. It means that you need to typecast to the test class. I'm closing the try catch statement. Then we have a catch. Then we have an exception. So I'm using the more generic exception instead of the clone not support exception. You can also use the clone not support exception. It doesn't make any difference. But if you use a specific one, that is more appropriate. Now you can see that first we have created in a class, implemented a clonable interface having two variables. Then we have a client class. In the client class we have a main method, public static void main method. In that I have created one object O1. Then I have called the O1.clone, and then I have assigned into the test another test object, and I have done the typecasting because clone method returns the object type. Now this O2 will contain exactly the instance variable as of O1, and they are the separate identity. That means they have same state, different identities. And I have used I have put this in a try catch block because it can throw a clone not support exception. So you can either catch the exceptions or a clone not support exception. Now this is a kind of a shallow cloning. How it is a shallow cloning? Suppose in our class we have some arrays. Just to remember that array is also an object, and it automatically extends the object class. Okay, now suppose we have an array with name called C, int C having value 1, 2, 3, and this is a way to initialize dynamic array, and then the array C will be created having 1, 2, 3. Now what happens if we by adding the object, and if you use the same process of cloning, which is called a shallow cloning, what happens? We can I can explain with the help of figure so that you can understand better. When the line of code, when the object O1 is created, what happens? There will be a memory space. There will be a memory space. In that, A variable will be having 10 value, B will be having 20. And as the array is an object, it will be stored. It will create and stored in a different memory location. So let's take an example. There is an array C. This is array C, and having the value 1, 2, and 3. Now C, the reference variable, will be in the object this one, and it will point to this. Right. So this is the way to store objects for the object instance variable and array object C for the O1. Now the first line of a code will create a memory location like this. Okay, now what happens when we clone an object O1? We have cloned this to an object O2, and O2 will be created, and the A is equal to 10, B is equal to 20, and C will be created, but we have not cloned this object. It means that now C will also point to the same memory location of an object. This is not a deep cloning, because in an object there is another object which is having a different memory location, and we have not created, or we have not cloned any of the object C in our code. So this is called a shallow cloning. Now in the next example we will see how we can write the deep cloning code. Okay. Okay. Now just to implement the deep cloning, we need to override the clone method. So just as we want to clone the object of the test class, so we need to add the implementation of clone method in the test class. we are overriding the clone method from the object class, as we did in the last lecture. The clone method belongs to the object class. We can return type can be an object or any or the test class object. Okay, just if it is returning an object, we need to typecast, otherwise it can return the test object, then we don't need to override it. Now with this method, with implementation of this method, says that first we need to call the default clone, like now you can see that whenever the super dot clone method will be called uh, from the client class, main class, we will write the main class in a moment. Whenever the clone method will be called on an object S1, on an object O1, what happens? This clone will be called, overridden clone will be called instead of the object class. Now the super dot clone will call the default implementations of the clone method in the object class, and O1 O1 dot clone will be called, and then it will create a clone of the O2. Similarly, in the same fashion what we did in the shallow cloning. Now these two variables, instance variable A and B, will be cloned for an object O2, and we need a reference of this variable array, which is an object. Now we can also call the clone method on this array object, because it is also an object. Array is also an object. We can also call the clone method on the array. Now C dot now you can see that how we have done the implementation in clone class. Now suppose we are calling the clone method from the main class. In the main class, in the public static void main, I am writing the code like this. So this I am writing the code snippet, not exact code, just to visualize how this how the clone is implemented. Now test O1 is equal to new test. Now with the O1 I have all the three instance variable of the O1 object, A, B and C as an array. It will contain this O will contain A instance variable as a 10, B as a 20 and C as a 1, 2, 3. Right. Now when I call the O dot clone, O1 dot clone, in a similar fashion the way we did in the shallow cloning. So now what happened, instead of calling the clone of the superclass object of this one, means when I call a clone method, and earlier there was no implementation of a clone method in the test class, the superclass, that is an object class clone implementation, is will be called. Now that implementation is not providing us the deep cloning, so that is why we have overridden the clone method in the test class. Now see, when I call a O1 dot clone, what happens? It will call the clone implementation of the test method, overridden implementation. Now it will call super dot clone. It means that this super dot clone will be called as an object class clone method, and it will create an object of O2. As why it will create an object O2 of an test, because we have called with the reference of the object O1. Now with this reference, the super will call a clone, and it will create an clone object of the O1. Because we have called with the O1, it will create just replicate of the O1, and it will we can get into the O2. Now this O1, this O2 object is similar to the O1 having the value A and B. In that we do not have these separate object C for the O2. Now we can also create a clone method on the array. So C1 dot clone we have called. C1 dot clone we have called. That means now first O1 is created with value A 10, B 20, and C pointing to the 1, 2, 3. This line of code, when we call this one, what happens? First this line is executed. O2 will be created with A 20, 10, B 20, and C pointing to this first line of a code. Now C dot clone will be called. So that means this cloning will be called. It will become 1, 2, 3, and this object is pointing to the O dot C. That means O dot C is here, and this is pointing to this one, and this will be break. Now you can visualize. Now you can visualize by using this O dot C2. Now we have separate deep cloning of an object O1. Now you can return O2. That means it will return the test. Now if I remove object and I can write a test, then we don't need to overwrite. So this is a deep cloning. The advantage, there are two advantages of cloning is that first, in comparison to the assignment operator, in assignment operator we cannot create an exact replica. Instead of that, we create an alias as a reference variable which can use the same object. First one is okay. The first advantage, again I'm repeating, the first advantage is with the assignment operator, where the assignment operators create an alias object, alias reference variable for an object. That means now you can have two reference variable O1 and O2 for the same objects, and that is not exactly a cloning. The second advantage of cloning is in context of the copy constructor. We can also clone the object with the help of copy constructor, but the copy constructor is a very tedious task. Why? Because suppose if you have 100 variables in a class, you need to assign each and every variable in the constructor to create a new exact replica of this one. But by merely calling the clone, automatically all the reference variable will be called. So this is the advantage of the cloning. Now now the second topic for today's lecture is the difference between the overriding and the overloading. Okay, the next topic for today's lecture is difference between the overriding and the overloading. First we will understand what is an overloading and what is an overriding, then we will see the differences. The overloading, as you have studied in the C++ also, that in a class we can have a method with the same name but with a different parameters and argument list. The number of parameters can be different or same, and if you have a two method with the same number of parameters, but the data types of the parameters should be different. Now overloading, when I say overloading, means that you are giving an extra load to the same method, and overloading and overriding both are the part of the polymorphism. Polymorphism means that one method can have a different form. Poly means many and morphism means form. So polymorphism can be of two types. First is dynamic, or another is static. Static means that whatever the compilation we've done, whatever the binding is done is at the compilation time, and otherwise in the run time. So these two belongs to the static and dynamic binding. As in the C++, you have studied late binding or early binding. So we will not use the word late binding or early binding. Here we have a static binding or dynamic binding. Okay, overriding comes into the picture with the concept of inheritance. When I say that a superclass is having one method called sum, and the subclass which is extending the superclass don't want to use the implementation from the parent class, but want to give a different implementation. That means the subclass is overriding the method from the parent class. Okay, now these are the 7 criteria to keep the difference between the overriding and the overloading. Let's start with the method name. In overriding and overloading, the method name should be same. It means that when you overload or override, the name of the method should be same. Now next is argument list. Argument list must be same. Okay, the next is argument list. Argument list in the overriding should be same. Okay, now what does it mean? Whatever the argument in the parent class and the list of the arguments are available in the parent class and the subclass want to override, the argument list should be same. Like suppose there is a function f with int x comma float y. This is in the parent class, and in the subclass you want to override, that you need to keep int comma int any variable x or float y, and then you need to give a new implementation. This is a new implementation. You cannot change these data types in argument list, otherwise it is not an overriding. But in case of overloading, the number of arguments can be same or different. We can see how it can be same or different. Suppose a method f is available with this one, another method f with int x, another method is float y. Now these 3 methods are overloaded methods. The number of parameters are different, that they are overloading, or even the number of parameters are different but having a different data type. That means still they are overloading. That is why they can have a same or a different number of arguments. The next is return type. The return type of the overloading method can be same or different. Means that the signature in the overloading doesn't make any difference when we have a different return type. That a function f either returning int or a function f either or returning float can be considered as an overloaded method, because return type doesn't take any responsibility in the overloading part. So that means the return type can have the same return type or it can have a different data type. But in case of overriding, it should either be same or a covariance. The meaning of covariance is, suppose there is a parent class x having the method int, return type is int, and you have a child class y, and you are extending with x, and now you have float f. It is returning itself an object s, and it is returning a y. That means now the return type of the function method y can be the same, exactly the x or the covariance, because x is a subclass of the class x. Now the y return type can also be held in the x. That is why these two are called the covariance. Now this type of the return type can also be possible in the overriding. Now next is a throws clause. Throws clause means when we have an exception, the exceptions are throws. So in a method, if we have a throws clause, we can have a same throws clause, or we cannot have a different, or we can narrow the scope of the throws clause. Like can have a same exception. So what is the meaning of the exception? Suppose this function f is throwing some exception a, throwing an exception a. Now the overriding function f should also can also use an exception A, means that throws A will work, or any exception which is a subclass of the A exception, then it can work. Like function f throws A. So A means it is throwing the same exception, or it can have the subclass of the A exception, because the exception in Java are also classes. So that means an exceptions can have a sub exception classes. That means we can throw an exception B, but B should be a subclass of A. That means either I can throw the same A or the subclass B. But in case of overloading, I can throw any new exceptions. It doesn't make any difference. Means it can throw same or different. Here, different exception means that the exception which are thrown over here in the overriding part, the exceptions can be same or different. Different means there is no relationship between the exceptions in the overloaded method and in the main method. Right. Now next is accessibility. Accessibility means that suppose there is a function f and I have created as a protected in the class x, and in the class y I have function f. So this is what I can write as a modifier. Now in the overriding part, I can write here protected, and I can increase the visibility. That is why I am writing less restricted. So what is the meaning of less restricted? Now we have a restriction in the accessibility. Let's see what are the different accessibility or different access modifier in Java. The first one is a private. The another one is a default. Then we have a protected. In the last we have a public. The accessibility is increasing. Here the accessibility is increasing means that because this is a part of the package, and package is a different lecture. Just to understanding, the private means that you can access within a class, default means that you can access within a package, protected you can access within a package plus subclasses in the different package, and the public means that you can access anywhere. That means gradually we are increasing the visibility. Now with this accessibility, I am writing less restrictive, means that whatever the accessibility it is having, I can put it the same, but I cannot restrict it. Less restriction means I can increase. So I can use the same accessibility, or I can use a public. Okay, once I have a public, I can only have a public, I cannot have a protected, default or private, because in overloading private method do not override. That means we cannot add this one. Even we are restricting the accessibility, which is not possible in case of overriding, right? So here less restrictive means that I can have the same visibility, same accessibility, or I can increase. Increase means I can go down. But in case of overloading, I can have same or different. Okay. Now next is a declaration context. Declaration means that where I can declare this one. This is very important to understand. The overriding can only be possible with the parent class and subclass. Means I have a function in the parent class, and then I can only override that function in the subclass. It means that subclass, right? But in case of an overloading, which is very important question in interviews and which is asked normally, where we can overload. So overloading can be done at both level. Like I have a class X, even I have a class Y which extends the class X. Okay, I have a function F and I have a function int X. This is overloaded. So overloading can be done at the same class. And even if I write F with float Y, I am still doing the overriding part. Okay, this is not an overriding. Sorry, still I am doing the overriding. Means this is F. I have different signature. I am overriding in the same class. If I use F float, still I am overriding in the subclass also. That means same class and subclass. That means overloading can be done in the same class and the in the same class and the subclass also. This is the question you will see in objective type questions in the interviews. Okay. Then last is the method resolution. That means where the method is resolved. This is very important to understand what happens. The things are bind. The objects bind with the methods. When I say overloading, that means we are doing at the compile time. When I say overloading, it is done at the compile time. And when I say overriding, it is done at the runtime. What is the meaning of compile time? Compile time binding means when we compile, the object is bind with the methods available in the class, which is done at the compile. Means when at the compilation, the object knows that which method will be called. So this is done at the compilation time. In overriding, in overriding we have a runtime binding. Just to understand the runtime binding, we must know the concept of dynamic method dispatch. The concept of dynamic method dispatch says that the reference of the superclass can hold the object of the subclass. Like this, X is a superclass, O is a reference of the superclass. We can have a new then object of the superclass. Now, if there is an overriding with this one, so this is a overriding. This is a overriding with F and F. Okay. Now, O dot F, we know that this is done at the runtime. We know that F will be called. Okay. Method F will be called, but which implementation, either from the parent class or from the subclass, this is resolved at the time of compilation. So this is a very important concept in Java, which is called a dynamic polymorphism or dynamic method dispatch or dynamic method lookup. So this is all about the different differences between the overloading and overriding. That's all for the today's lecture. Thank you for watching this.